Hey everyone, welcome to Math 104. We're working on section 5.2. We're going to be factoring some more trinomials. Last time, we worked on trinomials like this that had a 1 coefficient on the x squared term. And this time, we're going to be looking at these types of trinomials that don't have a 1 there. So for the warm-up, please factor that. And then we're going to play a little different game with these numbers this time. Last time, we looked for two numbers that multiplied to get c and added to get b. But this time we're going to work with the product a times c. So find two numbers that multiply to equal the product a times c, which is negative 12 in this case, and add to get 11. Alright, so to factor this, we need two numbers that multiply to get negative 35 and add to get negative 2. Since it's negative here, we're going to get one positive and one negative value, and they need to be separated by 2. So that's 5 and 7. So we've got x minus 7. The bigger number has to be negative because the middle term's negative. And when we add them together, we'll get a negative value. So we get x minus 7 times x plus 5. Now here we need two numbers to multiply to get negative 12, add to get 11. This is negative, so one number will be positive and one will be negative. And since this is positive, the bigger number has to be positive. So those two numbers are 12 and negative 1. We're going to look at two different methods of factoring problems like this. One is the box method, and it's a visual approach. And the other is factoring by grouping, which is a more algebraic approach. So you can select whichever method you like. But for today, please do both of them for every problem so you can get to know each technique very well. And then later on when you're doing homework and exams, you can just pick your method. Now, with any factoring problem, the first step is always the same. Look to factor out any greatest common factor. Here we've got a greatest common factor of 2, so we can factor that out. That gives us 2 times 2x squared plus 11x minus 6. All right, now we need to find two numbers and multiply to equal the product AC. And add to get 11. Well, we already found those two in the warm-up. That's 12 and negative 1. All right, so there's our two numbers. Okay, now this is where the two techniques diverge. We're going to have a different technique now. So, with these two numbers, they add together to equal the middle term. So that means that we can split up this middle term into two parts. And that's what we're going to do when we do factoring by grouping. All right, now I'm going to just leave the 2 off for right now and just work with the term inside the parentheses, but we have to remember at the end to bring the 2 back. All right, so we have 2x squared. Now we're going to break up that middle term into 12x minus 1x minus 6. So we haven't really done anything. We haven't changed anything here. All we've done is rewritten 11x as 12 minus 1. Now we've got a 4-term polynomial. We can do what we learned last time and do factoring by grouping. So I'm going to factor the first 2 and the second 2. Here we can factor out 2x and get x plus 6. And if we want to get a matching x plus 6, we'll factor out a negative 1 here. So I'll just write that as a negative sign and get x plus 6. All right, now we can factor out the x plus 6, the matching binomial. And what remains is 2x minus the implied 1. So there's the factored form of what's inside the parentheses. And to finish this off, we can bring down our 2. And there we go. All right, now the box method works similarly. There's some important differences. So create a box like this with a couple of flaps here. Now, we're not going to use this part right away, but we will need them. Well, we're going to work in here first. All right, so box method, take your x squared term and put it in the upper left of the box. Ignore the flaps. All right, now we take our constant term, lower right. Those two always go there. Now these two middle terms we just created here, from 12 and -1, those are the numbers that are going to go here. All right, so both methods use these two numbers. So I'm going to write 12x here and -x here. All right, so the x squared term always goes here, constant term always goes here, and the x terms always go there. And the x terms are those created with those two numbers. Okay, now we're going to find the greatest common factor in all four directions, ignoring the negatives. In this step, ignore any negatives, just pretend these are all positive values. So in this direction, the greatest common factor, there's no common factors there except for 1, so we just put a 1 there. Greatest common factor in this direction is 2x. Greatest common factor in this direction is x, and in this direction it's 6. Now the last step is to deal with the negatives. If you have a positive value here, this stays positive. So positive, 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 positive. But if it's negative next to this box, then you take that negative and put it up here. And there's our answer. X plus 6, 2x minus 1. And then we bring down our 2. And there's the factor form. Box method, it takes a little practice. But by the end of this lesson, I'm sure you all have it down. All right, your turn number 1. We're going to factor 12x squared plus 19x plus 4. Please use both methods. For this one, we don't have any common factors to factor out. So we'll go right to AC. A is 12, B is 19, and C is 4. So AC gives us 12 times 4, or 48. All right, now we need two numbers, multiply to get 48, and add to get 19. So those two numbers will be 3 and 16. So now we're going to break up that middle term into 3 and 16. So for the factoring by grouping method, right, this is 12x squared, and it got all positive values. It doesn't matter which way we write these. You could put the 3 here and the 16 to the right, or vice versa. I'm just going to go 16x plus 3x plus 4. But it'll work either way. All right, now I'll factor by grouping. Factor out a 4x here, and get 3x plus 4. Here, we don't need to factor out anything. But if you want to, if it helps you, just write that 1 out front. But that's optional. All right, now we'll factor out 3x plus 4 and give 4x plus 1. All right, so there's the grouping method. Now the box method. We put the 12x squared up here. We got the constant on the right, and then our two terms here. We got 16x and 3x. All right, now we can find the greatest common factor in 4 directions. Up, there's a 1. Up here, we got 4x. This way, 3x. And this way, 4. All right, so there's our answers. 3x plus 4 and 4x plus 1. So same answer either way. Your turn, number 2. We're going to factor 27x squared plus 42x minus 5. All right, so there's ABC. Got AC. Is 27 times negative 5. That's negative 135. Now we need two numbers that multiply to get negative 135. And add to get 42. All right, so we've got 45 and 3. And then one of those has to be negative, and the smaller number has to be negative. All right, because when we add them together, we want that positive value. So there's our two numbers. All right, I'm going to do the box method first this time. Make sure you're practicing both methods. Make sure you become adept at both methods before you choose between them. You never know. Once you get good at them, you might like one or the other. Okay, so let's put in 27x squared. And the constant term in the lower right. These two terms go in the other corner, so we got 45x and negative 3x. All right, now we're going to find the GCF in all 4 directions. In this way, we got 5. And this way, we got 3x. This way, 9 divides into both 27 and 45, so we get 9x this way, and this way just 1. All right, now we need to deal with the negatives. We got all positives here, so these all stay positive. We got negative here, so this one becomes negative. And there's our answers. 3x plus 5 times 9x minus 1. All right, now to finish off, using the grouping method, we're going to rewrite this as 27x squared plus 45x minus 3x minus 5. All right, now I'll factor by grouping. So I can factor out a 9x here to get 3x plus 5. And over here we have 3x minus 5, so we just need to change the sign. So pull out a negative, that becomes 3x plus 5. Now I've got matching binomials, so we'll pull that out. Oops. 3x plus 5 times 9x minus 1. Your turn, number 3. 15x squared minus 14x plus 3. So AC, multiply 15 times 3, you get 45. All right, now we need two numbers that multiply to get positive 45 and add to get negative 14. So those two numbers have to be either both positive or both negative. Since this is negative, they both have to be negative. So those two numbers are negative 9 and negative 5. I'm going to do the box method. I'm going to do the grouping method first this time. And now we will factor these by grouping. Okay, out of these two, I can pull out a 3x. That gives us 5x minus 3. And now we've got negative 5x plus 3, so the signs are switched. We need to pull out a negative, and that'll turn into 5x minus 3. We get 5x minus 3 times 3x minus 1. Just a reminder, make sure you're checking these by foiling. Especially important on exams. Don't want to miss any points for little mistakes. Alright, finishing off with the box method. Do it down here. 15x squared goes up top. 3 goes down here. And our two middle terms, negative 9x and negative 5x. Alright, GCF in all directions. And this way we got a 3. This way we got a 5x. This way we get 3x. And this way we get 1. Right now, taking care of the negatives, we got a negative here, so this becomes negative. Positive, 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 negative, negative. So we got 3x minus 1, 5x minus 3, just like we got with the other method. Your turn, number 4. 12x to the third minus 14x squared minus 10x. So just a quick reminder before you get too far, pull out the GCF first. Every factoring problem start with the GCF. We got all evens here, so we can pull out a 2, and we have x's in each of these. So we can pull out a 2x. That is 6x squared minus 7x minus 5. AC, 6 times negative 5, negative 30. Now we need two numbers to multiply to get negative 30 and add to get negative 7. They will have opposite signs because this is negative, and the bigger number should be negative. So it'll be 10 and 3, or 10 and negative 3. Okay, box method. 6x squared goes up here. Make sure we're working with what's inside the parentheses. Don't want to go back to the original and start plugging those in. Alright, we got 10x here, negative 3x here. Alright, this way, we'll factor out a 5. This way, factor out 3x. This way, the GCF is 2x. And this way, we got a 1. Alright, now negatives. The only negatives here, so we'll make this one negative. So that gives us 2x minus 1 times 3x plus 5. Alright. Grouping. Here we can factor out 2x, and that gives us 3x plus 5. Here we got negative 3x minus 5, so the signs are switched. We'll pull out a negative 1, and we get 3x plus 5. 3x plus 5 times 2x minus 1. Let's see here. Oh boy, I switched my signs. Oops. Yeah, made a mistake here. Bigger number should have been negative. I even said that. Okay, so we got a little damage control in here. There we go. So those are a good example of those little mistakes you can make that we'll catch if we check by foiling. All right, and then the final answer, we have to bring down 2x, and there you go. All right, last topic today, factoring by substitution. Substitution is one of the most important and powerful skills we can learn with this method. It's a great way to take our skills to the next level, because no longer are we restricted by dealing with or working with only what we're given. Now we can start making up equations as long as we follow the rules of algebra, and then we can start substituting when it's going to make things easier. And some of these problems, they look very complex until you substitute, and then we can transform them into something we've seen before. All right, now we're going to start by looking at quadratic forms. And a quadratic form is anything that has a squared term and then has the same base to the first power. That's a quadratic form. So for example, here's a base x minus 2. We want one term where we have that to the second power, and then another term where you have it to the first power, and then there might be a constant term on the end. So this has the general form of a quadratic, except it looks different. So let's make it look like all the other quadratics. That's where substitution comes in. So what makes it different is the fact we have a binomial here, x minus 2. So I'm going to define a new variable y. And this is something you should get used to doing, so do it enough so you feel comfortable doing it. And I've got y equals x minus 2. Now substitution, we can plug in into an equation or an expression anything that's equal to something else. Those two things can be substituted whenever you want. So we've defined y to be x minus 2, so everywhere we see an x minus 2, we're going to plug in a y. Y squared plus 6y plus 5. All right, now we just have a regular quadratic. So we can factor this. We need two numbers to multiply to get 5 and add to get 6. That's y plus 5 times y plus 1. All right, but when we factored, we didn't want this expression with y's in it. We want an expression with x's in it. So that means once we have it in this form, we need to go back here and plug in x minus 2 into these. It's called back substitution. So whenever we see a y, we're going to plug in x minus 2. So we got x minus 2 plus 5 here, and x minus 2 plus 1 here. And now we can simplify this to x plus 3 times x minus 1. All right, so give this a try with your turn number 5. So we're going to find a new variable now. Doesn't matter what it is, you can y or a or something like that. I'm going to use a this time. A equals x plus 7. And then substitute. Everywhere we see an x plus 7, I'm going to plug in a. So a squared minus 7a plus 12. Now we need two numbers to multiply to get 12. Add to get negative 7. That's going to be negative 3 and negative 4. So a minus 3, a minus 4. Now we can back substitute. Everywhere you see an a, plug in an x plus 7. So x plus 7 minus 3, and x plus 7 minus 4. And that gives us x plus 4 times x plus 3. So that's one type of quadratic form. Another type of quadratic form is higher powers. For example, we could do x to the 6th minus x to the 3rd minus 20. Notice here, the power here is double the power here. So that's a quadratic form. Just like with this quadratic, this power is double this one. So we're going to rewrite this so that we get a squared term and something to the first power. So when we substitute, you look at the middle term. That's what we're going to substitute for, x to the 3rd power, because we want to turn that into a single variable. So that's what we'll do. I'm going to define a new variable. This time I'm going to call it b. b equals x to the 3rd power. So when we substitute, we will automatically have something to the first power there. Now when we substitute, let's rewrite this x to the 6th power. Keeping in mind our properties of exponents that we learned in chapter 4, we can rewrite x to the 6th as x to the 3rd squared. Right? Power to a power, multiply the exponents to get x to the 6th. So those two things are equivalent. Now, what was x to the 3rd? Well, that's just b. So we'll now substitute, and that becomes b squared. So x to the 6th can be written as b squared. All right, now we know x to the 3rd is b, so that becomes b and minus 20. So there's our quadratic b squared minus b minus 20. Factoring this, you need two numbers to multiply to get negative 20, add to get negative 1, so that's b minus 5 and b plus 4. Now back substitute, and these are even easier because we won't even need to simplify. We'll just plug it back in, and we get x to the 3rd minus 5 and x to the 3rd plus 4. Your turn, number 6. All right, we are going to set our variable equal to x squared. So that's the variable part of the middle term. So I'm going to use a c this time. C equals x squared. And we substitute, and we get c squared minus 2c minus 35. Because x squared, x to the 4th can be written as x squared squared. So that's c squared. Now we'll factor this into c minus 7, c plus 5. That was our warm-up. Back substitute. X squared minus 7, x squared plus 5. So the substitution method, once you get used to it, makes problems like this much, much easier. Last page, we've got 4 practice exercises. Those are mixed type. So please go through and do those at your own pace. And then compare your answers with what I have. Number 7. All right, we've got a quadratic form. I'm going to substitute in for x minus 5. So y equals x minus 5. I'm going to declare that variable there. And that turns this into 4y squared minus 4y minus 15. So now we use the AC method. AC equals 4 times negative 15, which is negative 60. All right, now we need two numbers that multiply to get negative 60 and add to get negative 4. So we got negative 10 and 6. So now if you use the factor by grouping method, we got 4y squared minus 10y plus 6y minus 15. Now I'll factor this by grouping, so I'll pull out a 2y here to get 2y minus 5, and over here we can pull out a 3 and get 2y minus 5. So there's our matching binomials. 2y minus 5 times 2y plus 3. All right, now we need to back substitute. So everywhere I see a y, I'm going to plug in x minus 5. So that gives us 2 times, and make sure you put this in parentheses, we have to distribute in. All right, x minus 5 minus 5. And then over here we got 2 times x minus 5 plus 3. Distributing gives us 2x minus 10 minus 5. 2x minus 10 plus 3. Yikes, now what did I do? Oh, that's right. Yeah, that is correct. Okay, so checking this is quite a bit more difficult because we have to FOIL this and then FOIL that, distribute that, combine like terms, do a bunch of simplifying, so it's kind of involved. Number 8. All right, we've got a quadratic form with higher powers. So we'll take a variable, some variable, doesn't matter which one, set it equal to the variable part of the middle term, so x squared. And we'll rewrite this as 6a squared plus a minus 1. All right, AC method. AC is negative 6. So we need two numbers that multiply to get negative 6, add to get 1. So that's going to be 3 and negative 2. All right, I'm going to go ahead and do the box method this time. 6a squared goes here, negative 1 goes here, and then we'll take our two values, plug them in here. So we got negative 2a and 3a. All right, GCF in all 4 directions now. This way we get 1, this way we get 2a, this way we get 3a, and this way we get 1. Negative here, so that turns this one negative. Everything else is positive, so that all stays positive. 3a minus 1 times 2a plus 1. All right, so there's the factored form of this trinomial. Now we need to substitute back in. So x squared, everywhere you see an a, so that's 3x squared minus 1 times 2x squared plus 1. All right, we've got another higher power here. So use y this time equal to the variable part of the middle term, so x to the third power. So that gives us 16 y squared plus 16y plus 3. AC is 48, 16 times 3. Now we need two numbers that multiply to get 48 and add to get 16. I'm having a little trouble today. What do we got here? Oh, 4 and 12. So those two numbers are 4 and 12. All right, go back to the factoring by grouping method. 16y squared plus 4y plus 12y plus 3. All right, so we've broken up that middle term into 4y and 12y. Now factor by grouping. Let's take out a 4y here. You get 4y plus 1, and over here we can take out a 3. And then you get 4y plus 1. All right, now we can factor out the 4y plus 1. And we get 4y plus 1 times 4y plus 3. Now we need to substitute x to the third back in, so that gives us 4x to the third plus 1. And 4x to the third plus 3. All right, last one. Back to a quadratic form with binomials. So I'm going to set b equal to x plus 1. And that'll give us 10b squared minus 7b plus 1. AC method, 10 times 1 is 10. That means we need two numbers to multiply to get 10 and add to get negative 7. So that's going to be negative 2 and negative 5. So I'll go back to the box method on this one. All right, 10b squared goes here. 1 goes here. Negative 2b and negative 5b. All right, each direction we'll find the GCF. So we got 1 here. We got 5b here. This way we got 2b. And this way we have 1. Negative, negative, positive, 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 negative, negative. So that is 2b minus 1 times 5b minus 1. All right, now back substitute. We need to plug in x plus 1 for b. So that gives us 2 times x plus 1 minus 1. And then 5 times x plus 1 minus 1. Distributing, 2x plus 2 minus 1. And over here we get 5x plus 5 minus 1. Simplifying, 2x plus 1 times 5x plus 4. All right, so we've seen a lot of new techniques. They're going to take some practice. Just keep working on them until you're comfortable with them. So we're going to be using these throughout the remainder of this chapter, next chapter, and all throughout college algebra.